Hello everybody. I'm sorry I'm dealing with something right now, and I need to send this email before we get started. So while you're waiting for me to finish this, it'll just take me a minute or two. Does anyone have any questions that they want to ask about the test or the assignment or any of that? We will be going over some of that stuff very briefly. Just if you've got those questions, feel free to type them out while I send this email off. All right. Hello, Coda. Hello, Allie. Welcome. Let me put this down, and let me tell you a little bit about what I'm dealing with right now, if you guys don't mind. The university, as I'm sure many of you know, let's see how we're doing here. Yeah, I'm sure many of you know about the code grade software. Now, I've never used it before, so I can't talk bad about it. But they would really like me to use that for this class, and I'm arguing very much against using it because I like making randomized assignments. So I guess I'm just going to give you a warning then. We may have to implement code grade, but right now I'm making an argument for not using it. So I hope that I come out on top. But we'll see, because I'll do what the university would like. So we'll get started with today's class. And the first thing that we'd like to go over is Allie would like to go over making a deep copy. So I actually, if you don't mind, let's take just a few minutes to get your feedback about CodeGrade. Some of you may not know what it is, but it is a software that automatically grades your programs right away. But as I understand how CodeGrade works, is it does specifically output matching. That's, I'm sure it has the ability to do some other things, but it would make you match my output exactly. And I'm a little upset with it because, for example, that card shuffling program that we did, I thought that was kind of a fun, engaging assignment. And you guys were welcome to shuffle the cards however you wanted. And I kind of wanted you guys to try to beat my high score. I think there's some amount of engagement to that. I know some of you really don't care and you just want to pass the class, but for me, coding's very fun. And so I thought, if you guys try to beat my high score, then, you could have some fun with that. There'd be some motivation surrounding that. And if I were to use CodeGrade on that assignment, it would probably mark you because your card shuffle would not be exactly like mine. And your outputs would be different because you are rating the card shuffle based off your own card shuffle. So in a way, it kind of limits me to designing the assignments. And it also forces you guys to match my output literally exactly, like down to the exact characters. And I know some of you have other things to focus on. So it does have its ups and downs. And yeah, it does give you the feedback immediately. So I don't know. It might be like Zybooks. I'm not sure. But right now I'm dealing with that, and we may have to implement CodeGrade here very soon. And if I do, then I will introduce it to you guys, just so you guys know how to use it. and we'll take some time in class for that. So the first thing we'll do is we'll talk about making a deep copy. As you know, the test was yesterday. Many of you did pretty well. I've already seen some A's. I've been grading them. So I'm happy about that. So that grade should hopefully go up today. And you'll get to see that. Now you can look at the answers, okay? So I'm not going to really go over them in class unless there's like a really specific one that you didn't understand my answer for. But we will start with the deep copy like Ali asked. And so maybe we can get a good example of that real quick. So let me get set up here. Also, let me brag for just one moment. Before we get into class today, I want to brag for one moment. I'm very proud of this. I'm very proud of this thing that I've done. And you guys hopefully will get to do this assignment. Today we're going to go over virtuals. And so I've been working on that assignment. And I think I've made the coolest program I've ever made in my entire life. Maybe that's not true, but we'll see. So I know we have plenty of gamers out there, and I know some of you aren't gamers, and that's fine. But I basically made terminal Minecraft. So we're gonna do this program, and you'll understand how it works in just a moment. But basically, you generate some ground. So these are dirt blocks here, and then all the 1s, the 2s, and the 3s are stone blocks, and then all the X's are bedrock. And hidden in each of these numbers, kind of like Minesweeper, are different ores. And so you can literally control this program, and you can like dig down, and you can find ore. Let's see if I can find some ore. My output's a little large. So you can see that I'm just digging around here. And look, and then you can find ores inside of the rocks. And you need to find specific ores. So I can't dig up this number 2 block because I haven't found a pickaxe upgrade yet. So I have to keep moving around until I find some ore. And once I do, I'll be able to move down. And so this program I've made is completely randomly generated. I think it's pretty fun, and there's no way CodeGrade would be able to even remotely grade this assignment. I know at this point I'm just kind of rambling a little bit. Maybe you guys don't really look forward to doing assignments like this, but honestly, designing the assignments is kind of the highlight of my day. Other than getting to hang out with you guys, of course. Alright, so we're going to get set up for today. That assignment won't be available yet, so I still have some work to do on it. So right now, we're just going to talk about the strings assignment today. And then we're going to learn about virtuals. So today is the 22nd. And the first thing we'll do is talk about deep copies. So let me zoom in here. Let me grab my favorite stuff here. Got to get warmed up a little bit. It is Monday, as I'm sure you all know. Oh, it's Tuesday, actually. It is not Monday. I saved the test for Monday. All right, so this is for Ali and anybody else who needs to know about deep copies and shallow copies. There's the images on Web Campus. If you want to use them, you can to reference those, but specifically I'll just stick to the code. So usually with a shallow copy and deep copy, it involves pointers. And so I'm going to just declare some pointers, pointer 1 and pointer 2. And so just to give you the idea, right, whenever we have pointers, we're usually allocating memory, right? This is when we get an address. I know that that part still might be a little confusing to you because we can also assign the address of something to this pointer, right? If I came up here and I declared a static variable x and I assigned it, say, 4, down here I could say something like this is equal to the address of 4. Not the address of 4, but the address of x. And so, let's say we allocate something into here, and then I dereference it, and I assign some value, say like 6 in there. And now what I want to do is I want to make a copy of pointer 1 in pointer 2. So I want pointer 2 to be a copy of pointer 1. So this right here is the shallow copy. Immediately, it's an alias, and I'm going to just say pointer 2 is equal to pointer 1. Now, the reason that's a shallow copy is because these are pointers, okay? These are pointers. They're not actually, I mean, they are variables, but they're pointers. So they're holding addresses. They're not actually holding this value. Rather, it's just kind of a roadmap to the memory so we can go get that value. So shallow copy just copies the address. And so now whenever I change pointer 2, if I say pointer 2 is equal to 7, I'm also going to change pointer 1. This changes pointer 1. Changes the value at pointer 1 as well. So that changes that value. And then the moment I come down here and I say pointer 1 equals 3, I say that changes the value at pointer 2. So you notice that these are copies, but they have just the location. And so they're aliased. And so whenever I'm altering pointer 2, I'm altering pointer 1. And whenever I'm altering pointer 1, I'm also altering pointer 2. So if I wanted to make an actual deep copy of that, if I wanted to make an actual deep copy and not just a shallow copy, yeah, it's a shared address. They both are looking at the same, they're looking at the exact same location in memory. And so to make a deep copy, for a deep copy, you need 2 addresses, not just one. In the shallow copy, you only have 1 address. There's only 1 address. So I need 2 addresses. So before I do anything, I have to say pointer 2, you get a new address. You say, here you go. This gives pointer 2 its own address. And so now pointer 2 has its own address. I can then dereference it, and I can say that's equal to whatever is stored at the dereferenced pointer 1. So notice in the shallow copy, down here, never once do I give pointer 2 its own address. Never once do I give it its own address. And when I make the copy, there's no dereferencing happening. Notice that there's absolutely no dereferencing happening on this side. But when I make a deep copy, I give a new address to pointer 2, so it has its own. And then to make the deep copy, I dereference pointer 1. So in a deep copy, there's always an allocation, and there's always a dereference. In a shallow copy, there's neither of those. In the shallow copy, there is no allocation for pointer 2. There's also no dereferencing happening. So, Ali and anybody else, does that make sense, what I'm describing? Feel free to ask your questions. Synchro says allocate. So allocate means new. To put it in English, allocate means request memory from OS. In other words, it means calling new. And deallocate means return memory to OS, and that means you call delete. So whenever I say allocate, it means I'm calling new. Whenever I say deallocate, it means I call delete. Synchro asks, doesn't shallow call new? Well, the answer is no. Now, yeah, I thought I might be a little confusing in this sense, so let me just give you an example of that. Let's pretend I have this X here. So, you're kind of right, but let's just pretend I have this. So if I say pointer 4 or pointer 1 is equal to the address of X, here I've made a shallow copy in a way. And you don't really see the new. You don't really see the new here. But this is a static, so in a weird kind of way, new is called before runtime. And so if I were to make a kind of a better option of that, shallow only involves a single allocation. Deep involves two allocations, right? Shallow will only involve a single allocation for whatever variable you're shallow copying. The deep involves two allocations, the original variable and then the copy variable. So I hope that answers that question. So now I'm going to discuss assignment 4 real quickly. I'll run it for you. This one, well, I'll just read it for you to start. And I'm warning you right now, for those of you who are here, this assignment is not going to be a walk in the park. Now, I know that the last assignment, I did claim it would be a walk in the park, and for some of you it wasn't. I know for a lot of you it was, though, right? All you had to do was add some classes and change, I think, nine players to different ones, right? So for assignment 3, you definitely could have finished that very quickly as long as you knew what was going on. This one is not going to be a walk in the park at all. So please get started on it. If you're having trouble, let me know so we can give you some more time. And also, since we didn't spend very much time on pointers. I mean, we did spend time on it, almost 4 days. But pointers are difficult, you know what I mean? So I will willingly do one of these functions for you. So as I'm talking about it, I'll tell you which ones I'll be willing to do, but only if you get started on this, and then tomorrow, on Wednesday or on Thursday, you come to me and you say, hey, I really had a problem with this function. I will do it for you guys. In essence, it will help you with the other functions too. So let me kind of explain what this assignment's doing, and I'll go back into more detail about what I was talking about. So in this assignment, we're not going to be doing anything fun, all right? We're not shuffling cards. We're not rolling dice. We're not querying an Olympic database. What we're doing is making a string class. That's the only thing we're doing. Super exciting, I know. So the main focus of this assignment is dynamic memory, meaning you're going to be calling new, you're going to be calling delete a lot. A lot. It's going to be everywhere in your code. You will be working explicitly with character arrays, which are navigated using a pointer inside of your string class. So let me go ahead and pull that up. So here it is. This is the pointer. This is the character array pointer. So whatever the string is, it will be stored in this member variable. All right? Whatever the string is, it will be stored here. Notice there's a size variable as well. So not only will you be graded on your assignment working as the output shows, but also the Valgrind output. So I will be going over Valgrind today a little bit. And we're going to make sure that all of your memory operations are proper. Meaning you're allocating things properly, you're making deep copies, you are within bounds, and you're properly deallocating memory too. So any errors that I see in Valgrind will be subject to point deductions. And the last thing is you may not use the STL string class once in this assignment. If I see that, you will lose points. What do I mean by that? The STL stands for the standard template library. And so if in any of your functions I see you do this, string my string, I will deduct 2 points. You are not allowed to use this. You are not allowed to use this data type. Notice that this is green, right? This is a class. I'm basically making you make this class. With the knowledge you have up until this point, you can do it. But if I allowed you to use strings, it would be way too easy. Singer asks, can we use Valgrind? Yes, you can. I will show you how to use it today. I do need to do something. I gotta be careful with this. 1 second here. It's fine. Okay. Okay. So there's 3 files, just like in assignment 3. All right. So you're gonna kind of compile the exact same way that you've done for assignment 3. You're gonna have the header file, right? That's this thing here. Here's the header file. And you don't have to do anything in here, all right? This is just the class prototype, the class declaration here. And then you have the actual CPP file. Cherry asks, basically we use a car pointer. Yeah, here it is. You're using a character array. It's wrapped in this class though. It's wrapped in a class. So the header file is there, and then all of your function stuff goes in the CPP file, all right? So here it is, right? And all your code will go into these things here. And then when you're ready to compile it, I'll show you. And I kind of gave you 2 of the functions already. So I ask you first to look inside main, all right? Let's look inside main. Now, I've given you main 2. All right, I've given you 100% of this. And pretty much I've commented every single operation that happens. So notice here I declare a CS202 string, and I call the parameter constructor. And then I call print string, and then I call the default constructor. And then I call this function called pushback. And then I call the copy constructor, but before that I call a concatenation. Before that I call a concatenation. And within those concatenations are parameter constructors. Sorry, and there's that expression there. Down here I call the assignment operator. Down here I call get size and delete at. So you can see that for every comment I include, you can see exactly what function I'm calling. And so as you're doing this assignment, maybe do this. Comment out everything from, say, line 12 to the bottom. I probably have one small problem here, and that's that. Yeah, okay. So just make sure you comment everything out, and then now you're only left with this thing. So do your parameter constructor, see if it works. And then when you're ready to move on to the next thing, do your default constructor. See if it works. Comment that part out. And then when you're ready to move on, go to pushback. See if that works. And then comment it out. Am I making sense? And then after that, do your copy and your concatenation. Copy that part out. See if it works. So on and so forth. So just look inside main to see what's being called. And now I talk about null terminated strings here. All right. So let me give you a quick example of that in this little program here. So when I say something like string G is equal to, say, Patty, string is a class, all right? So in all coding, we have some things called primitive types that can be directly translated to memory. So that might be an int, which is just 4 bytes. This might be considered what's called a primitive type. Now, you don't have to memorize that. You'll go over that in later classes, CS 326 specifically. But this might be considered a primitive type. Notice it's blue, right? Now, the moment we declare a string, it turns green, and that's because it's a class. And so this is a literal, right? This is a literal string. And as this is just the highlighted part that I'm talking about right now, this is not recognized as a string in the program. It's not recognized as a string. Rather, this is recognized as a character array. All right? So whenever you see double quotes means it's a character array. So in the assignment, I asked the question. I call a constructor here, right? It might look better like this. I call the constructor here. Now, look when I highlight this. Let's see. Well, first, let me highlight this. Notice that this is an array of 6. Does anyone know why? I mean, I kind of gave it to you already. But notice that Patty is only 5 characters long. Does anyone know why it says 6? Why is there 6 characters there? If you read that passage I was just looking at, you'd know, which I didn't expect you to, but Synchro says null, right? Yes, and that's because there's a null character at the end. There's a null character at the end of this string that the compiler is hiding from us. Or the program is hiding from us. C++ is going to sneak this in there. It's going to sneak it in there. And the purpose of that is to tell us how long the string will be. And so notice here, if I unhighlight this, I wanted to see the constructor. Show me the constructor. Well, it may not. And if that's the case, then I'm just going to Google something for you guys real quick. So if you're ever wondering, yeah, so Ali, that is what is a null character. It has the backslash on it. So it looks like 2 characters, but it's actually just 1. So if you ever were wondering about stuff, you can go string C++. You can pull this up. And you can look at all of the stuff in here. So if you want to look at constructors, you could click here. And then it will show you literally every constructor that a string has. Notice specifically this one that I'm kind of looking at. Might be kind of hard to see. Maybe I can zoom in just a little bit. Notice that this constructor takes a character pointer. This is an array. This is an array, right? And so that's the constructor that I'm calling. And what the string does is it goes through there and it looks for the null character. Once it finds it, it says I'm done. And so pretty much what you have to do for 2 of the member functions in this assignment is find that null character to determine how much memory you're going to allocate. All right. If I wasn't clear enough, you can just read this little passage, and it should tell you kind of about it. Ali says, we can do it like that, though, right? Well, there's a few things. This is still a character array. This is just a character. So it can be represented as that. But I guess that wasn't your question. So here says, when you said we can't call string, when we make an object, do we use the CS2 as toString? Yeah, if you want to. My tongue got twisted there. Notice in this function here is called concatenate. You can make a CS202 string within this function. You just can't make a normal string. You can make all the CS202 strings you want, but you cannot make just a regular string. If you use a regular string, you'll lose points. So here's the whole class, right? You can just reference it inside of that header file if you want. And then in every single one of these things, I provide you a description of what you're supposed to do. So I'll read you the parameter constructor as an example, but then now it's going to be your job to get started on this assignment and then tell me which of these ones is most scary for you. Now I'll tell you, I'm not going to do number 10. Number 10 is just an algorithm. Number 10 has nothing to do with memory. So I will not do find substring for you. And I would prefer to stay away from the concatenate too. But anything else I'll do. So if you want me to do the delete, I can do that one for you. The pushback I can do for you. Or the parameter constructor or the copy constructor. So get started on the assignment. You tell me which one of these is most scary that I just mentioned, and I will do it for you guys. And then you're going to have to rely on that explanation to work on the other ones. But for example, if we look at the parameter constructor, notice it takes that character array as a parameter. So figure out how long it is. How do you do that? Find the null character. Once you do that, save the size, allocate enough memory to store that array, and then deep copy the contents of the parameter array into the pointer array. When I say parameter array, I'm referring to this thing here. When I say parameter array, I'm referring to this thing. And when I say pointer array, I'm referring to this thing. Okay. So I'll just run that program for you real quick. Let me see. So how do I compile this? I'm going to compile it exactly the same way that I did the last assignment. So C++11. Now, I want you guys to start doing this. I included this in the compilation statement, all right? So don't write it down because you can just come down here and look at how I compile it. It's right here. But what I'm going to do is I'm going to add in a -G here. I'm putting a -G. And what this -G does is it says, please let me know the line numbers of my mistakes. So the -G does what is called inserting debug symbols. It makes the output file a little bigger. So when you're making production code, oftentimes you will not compile with -G. But when you're debugging your code, you will compile with -G. So I do that. That tells me where what line numbers I have problems with. And then I'm just going to type the name of the file. So we've got main.cpp, and then we've also got cs202 string.cpp. Once it compiles, I can run it. Now, your output will look exactly the same as mine. And it's just a little dialogue I made. This program just uses strings. How exciting. And after kind of some of the hard functions, I say, wow, you made it through that. Nice job. Hopefully valgrind says no memory leaks. And so that's just the output. That's what the output will look like. It will look exactly like mine. And I call all these functions. But when you're ready to use valgrind, here's what you do. You type valgrind. And then you're going to want to do it exactly the way I put it in here. Now it's kind of hard to tell. This is a double slash, a double dash. Like Mario Kart double dash. This is a double dash. So what you type is, let me clear it. You go valgrind, dash dash, leak, dash, check, equals full, dot slash a dot out. And then you'll notice here, we'll kind of have to look at it. But up here, it starts. Where does it start? Right here. Memory error detector. And so this bit is from valgrind. And then it runs all of your output. Now, if anywhere in here you do an invalid read, you free something, I'll try to give an example of that real quick. It will tell you what it is. It's going to say conditional jump depends on uninitialized values. What does that mean? Well, you probably forgot to initialize a variable. Invalid read, what does that mean? Well, you probably are reading from a location in memory that the program doesn't have access to. And then at the very end, it will say heap summary. And it says, hey, you lost some stuff. So notice here, this is the golden message. It says all heap blocks were freed, no leaks are possible. So let me go ahead into this deep copy program, and I'm going to generate some valgrind errors for you. So that will be okay. Now let's say I forget to delete some pointers. Let's say I forget to delete some pointers. So what does this program do? Well, it declares 2 pointers, it allocates them, it makes a deep copy, and then I forget to delete them. So let's see what valgrind tells us. And let me see how we're doing here on Twitch. Okay. So let's see what valgrind tells us. So I'm going to do my G++ dash std equals C++11. Now I'm going to add my dash G. Now, I'll forget to add the dash G, and I'll tell you why that's a problem. So let's say I forget to add the dash G, and I just compile my program as is. And now when I run valgrind, I'm just going to find my same statement from before and run it. Now notice what it says here. So notice down here at the bottom it says definitely lost 8 bytes. Why did I lose 8 bytes? Well, each int is worth 4. If I look in my code, you'll notice that I made 2 allocations, right? There's 4 bytes there, and there's 4 bytes here. And then they didn't get deleted, so I definitely lost that memory. And now it's trying to tell me what's going on here. So it says from main. It says from main, let me pull up. I want to make sure my face isn't blocking anything. So it says from this location in main, from this location operator new, 4 bytes were lost. From this location in main, from operator new, 4 bytes were lost. Notice that this is a hexadecimal address. This is a hexadecimal address. And you say, I don't know how to read that thing. So when you compile, you come up here and you say dash G. And then you run valgrind. And there we go. Now look what we can see here. Well, hold on one second. I should be able to see my line numbers. Am I sure that I compiled it? I should have. I'm going to make it a little bit smaller. I can't see what's going on here. So if I compile it, oh, I just didn't reload it. That's, well, maybe that's a mistake. Maybe it's not. Okay, there we go. Yeah. Okay, I can see it now. So if I zoom in here a little bit, notice, do you see it here? Yeah, you're right, little tacker. I'm a little spacey right now for some reason. Do you see here? It says line 20. So if I go look in my program at line 20, notice here I called new. If I go look at line 16, notice here I called new. So what is that telling me? It's telling me that I didn't deallocate these things. It's telling me I didn't deallocate these things. So if I delete them, I bring it back in here, I recompile it, I run valgrind, and notice all heap blocks were freed. So now you can generate some additional errors. Let me show you one of those. Let's say I'm going to access memory outside of something that I'm not allowed to. All right, so remember that pointer 1 is a single integer. So let's say I go 4 bytes outwards. So there's going to be one error. Now let's say I say bool, my bool. Notice that it's uninitialized. Uninitialized. I'm going to say uninit. And then if I say something like if my bool, cout, hello. All right. So notice that this is uninitialized, and then I make a conditional jump based off of an uninitialized value. And notice here I make an invalid read. So once again, if I load this into valgrind and I run the code, I should be able to see both of those things. Notice here it says invalid read of size 4. Tell me where. Line 21. Let me go look. Line 21. Notice I make an invalid read right here. I went out of bounds of the memory that I was allowed to use. What's the next error say? Conditional jump or move depends on uninitialized values. Where? Line 24. What does that look like? I go to line 24. Notice that my bool is right here. It looks like I uninitialized it. So those are roughly some of the errors that you'll see. Do you guys roughly understand how to use valgrind? You see how I do it? I compile with a -G and then I just run this command here. And then you can see what it's going to tell you. It's going to tell you if there's memory leaks. It's going to tell you if you're doing bad stuff in your programs. All right, so when you're doing the assignment, say your output's correct. Next thing you should do is check valgrind. And valgrind's going to say, whoa, you did some problems. And if you include the line numbers, you can kind of get a better understanding of where you have to go look. All right. Oftentimes, if your program segfaults or you're getting invalid reads, I'm going to ask you to send me the valgrind output, and then I'm also going to ask you to send me a screenshot of what it's looking at. For example, if you say, Mr. Petrowski, I'm scared, this valgrind output, I don't know what it means. I'm going to look at it, and I'm going to say, please send me a screenshot of line 16. And so you'll send me a screenshot of line 16, and I'll go, hey, this value didn't get deallocated. Something like that. All right, so use valgrind as a tool to help you understand what is going on in your code. So now we're going to finally move on to the subject for today, which is virtuals. It's virtuals. Now this has to do with memory too, so you're going to see a lot more of it. But let's just get some notes started for today. I do need to pull up my own notes as well, just to make sure I stay on track, because I don't want to lose you guys. All right, so that looks like a good time. Yep, all right. So virtuals is actually a pretty small subject, all right? It's a pretty small subject, but you are going to have to kind of reach outside the box to understand what we're talking about. And before I do that, do you remember the gamer code example from a few classes ago when we were doing inheritance? Do you guys remember the gamer code? And we made warriors, rangers, and mages. Do you remember that? Because today I'm going to kind of go back to that a little bit. Just a little bit. So today we're learning about virtuals and abstract classes. So the very first thing we need to do is when we talk about virtuals, we always have a class plus inheritance involved. So if you thought you got away from the inheritance, you funny. We always have a class and inheritance involved. So if you thought you got away from that, no, you didn't. There's also dynamic memory involved, always. So guess what? We're just building on everything that we've already learned this semester. We're building on dynamic memory. We're building on classes. We're building on inheritance. You can't get away from it. I'm so sorry. So, the main idea from this is there is always a pointer to a base class. All right. And now before we move on, before any of that, has anyone heard the term polymorphism before? And if so, could you describe what it means in 1 to 3 words? Do you know that term, polymorphism? What do you guys think it sounds like? What do you guys think it sounds like? Isn't that like a Hearthstone spell? You can turn a minion into a sheep. Synchro says many forms, right? That's good. That's good. Having many forms. That's great, in fact. So polymorphism is something that has many forms. So what are some examples of polymorphism? In C++? Well, I would say function overloading is a way of a function to have many forms. A function can have different forms. I would say that inheritance is a way for classes to have different forms. A mammal and a cat. A cat can be a cat, or a cat can be a mammal. So in that sense, the cat is taking 2 forms. All right? There are also some other forms of polymorphism. That would be operator overloading, which we really haven't talked about yet. So that's coming soon. Templates. That's also coming soon. And today we're discussing pretty much the polymorphism that's involved with inheritance. And so, I'll ask the question, why do we need virtuals? And is that, can some object take the form it needs during runtime? All right, so I'll clean these notes up a little bit later. But that's the question that we answer when we use virtuals. Is there some way an object can take the form it needs during runtime? So I'm going to introduce, or not introduce, but kind of refresh you guys on the gamer code. Does anyone remember the problem I had with my gamer code? There was a problem I had. If you don't remember, it's fine, but I'm just wondering, because the problem I had specifically involves why we use virtuals. Let me pull it open here. Is this my gamer code? That's not my gamer code. All right, so let's do a quick refresher then on the gamer code. If you recall, we had a player class. Right, this is similar to assignment 3, right? There's a player class. But in this example, we had players that have health, they have weapons, and they have names. Synchro says, did it involve something with the ranger? And that's correct. It did involve something with the ranger. Now, let me explain to you exactly what that problem was. So if you recall, similar to your assignment 3, each class kind of had their own special powers. The warrior just had big health, right? The warrior had more health than other players. But the ranger had the ability to dodge damage. Do you remember that? So the ranger had the ability to dodge some damage. And the mage had the ability to deal some extra damage. So those were the special abilities. Now, if you remember in here, I was trying to do something like, notice here I called mage deal damage to the ranger. And when we run this code, we actually never see the ranger special ability proc. It never happens. It never happens. And it fools me every semester. You can ask my previous students from my previous 2 semesters about the day we talked about inheritance, and I pulled out the gamer code, and they will literally tell you sorry. All right, connection's still good, guys. I'm sorry. My computer took a nap. It always does that. Thank you. So if you remember, I compile my code, the gamer code, and I run it. And you'll notice here, this is player 2, right? This is our major. And the major is using a lot of their special powers. He's using a lot of their special powers. But I never see the ranger special power happen. And why is that? So if we actually follow the code, notice we have a mage here. Notice we have a mage. Now I'll give you a hint. So first off, do you think this code works? Yes or no? We're kind of going back to our inheritance roots here. Does this code work? Yes or no? I'm going to give you a few moments. Synchro says no. Are there any other opinions? You have no idea? Well, I'll give you a hint. Mage is a player. Is that correct? Mage is a player. Isn't inheritance one way? So if I said this, player M2, let me not do it that way, but let me do it this way instead. If I said mage M2 equals player, the first thing it's going to say is, look, no suitable conversion from player to mage. Because it's one way. So player is not a mage, but mage is a player. So this works. This works 100%. This one does not work. All right? Inheritance is one way. But guess what? The moment I do this, notice that this player is a mage, right? I said, please initialize to be a mage. Am I still going to see the special powers? What do you guys think? Will I still see the special power of the mage? What do you guys think? Now, I know you're going to wait for me to run the code, but I like the answer. Lil Tucker says yeah. Mengisto says yeah. Well, let's take a look. Sigro asks, that's actually the most important question here. Where was the special power function? Where was it? Well, let's run the code. There are no special powers being called. So I successfully fooled you guys twice. And let me tell you why. All right, so notice we assigned player to be mage, but what type is M? M is defined. This is the big word here. It is declared as a player. So when I call deal damage from M, it refers to the deal damage that's within the player class. Here it is. This is the player class deal damage. This function right here. Notice that there is no special powers happening in here. But if I declare this player to be a mage instead, M is declared as a mage. And so in that case, it's going to refer to the deal damage from the mage class. So we go up here, and we're going to say, there it is. Notice here there is a chance for a special ability. So please tell me if I lost you there. Please tell me if that didn't make any sense to you. You should be a little confused, though. That's the truth. So notice here, in the deal damage function, what type does this deal damage function take? What type is this parameter? Does anyone know? Can anyone guess? What type is this parameter? Now it is taking a ranger, but is that its type? What type does this function take? And I flashed over it a few times. It's not a trick question. But it is the importance of understanding why this function runs the way it does. Lil Attacker says player. That is correct. Notice it takes a player. Right? He's right. It takes a player. Or they're right. So what happens to this range? Well, this ranger gets passed in and it gets casted to a ranger. This thing happens here, right? Do you remember seeing this? The mage is upcasted to being a player. And so the moment that the ranger is upcasted to a player, down here we're going to call player.receiveDamage. So are we looking at the received damage that's in the ranger, or are we looking at the received damage that's in the player? Well, I won't wait for you guys because it's obvious. We're looking at the received damage that's in the player. So the Ranger's special ability never has the chance to be procced. It never has the chance to be used. Because the Ranger gets casted to a player, and then we call player.receive damage. We do not call Ranger.receive damage. And so I hope you followed that. And today we're talking about virtuals, and virtuals help us fix the gamer code. All right? So at some point we will fix the gamer code. I'm going to kind of step away from it for now so we can start from the basics. The first thing I'll start with is some notes. And then I'll start with a basic example if we've got the time. And then tomorrow we'll finish up that example and then we'll fix our gamer code. All right? Singer says basically fixes auto casting. Yeah, I would say that virtuals determines what type the object is. Virtuals determine what type the object is. And what I need for this code to happen is I need to say, hey, I need it to say, hey, this is a Ranger class. So Mengisto says, can't we use the scope resolution operator to fix it? Now, that's a great question, but then I'm going to show you the issue with this. What if I called m dot deal damage on the warrior? What if I called m dot deal damage on the warrior? So the warrior gets passed up here. And then what do? I say something like, well, this won't work. The reason this doesn't work is because players are not Rangers. It's a one-way inheritance, all right? Players are not Rangers, therefore the one-way inheritance will not work. Now I may be able to convert this. I may be able to say this. But only Rangers can be Rangers. If I pass in a warrior, like I've done here, the warrior cannot be casted as a Ranger. So, Megisto, does that make sense why it's a problem? Because it's not general. The mage should be able to deal damage to warriors and to Rangers, but the Ranger needs to have the ability to have its special power be called. Pretty much. Now we could fix this. Look at this. Tell me what I just did. If I did this, what did I just do? Let's look at both of them. It's kind of hard to see. What thing did I just do? What's this called? We just took a test yesterday, right? We should know what I just did, right? What is this? I'm going to give you a few moments here. We should know what this is. It works. Attacker says overloading, right? That's exactly right. It's overloading. I overloaded this function. I said, hey, please have an option for a Ranger. Please have an option for a Ranger. And guess what? That fixes the gamer code. Let's see if it fixes the gamer code now. Oh my gosh, look. Look, everybody. It worked. Can you believe that? Can you believe that? It worked. But I'm still upset. Why am I upset? Why do I have to copy paste this? Why do I have to copy paste this? It's the exact same code. From this line to this line, and from this line to this line, it is the exact same code. That sucks. Why do I have to copy paste that? And what if I had 17 What if I had 17 classes? What if I was playing Overwatch and I had 17 classes that all have special dodge abilities? So what am I end up doing? I copy paste it. Oh, this is for the Tracer class. And I copy paste it. I say this one's for the Roadhog class. Am I having fun? No, I'm not. This sucks. You telling me I have to copy paste for literally every single class I have? I'm not going to do that. And that is why we have virtuals. All right? That's why we have virtuals. That's why we have virtuals. In which we're going to allow this player parameter to have multiple forms. All right? We're going to allow this player parameter to have multiple forms during the runtime. So let's get back to our notes then. So I kind of already went over that. So what exactly is a virtual? Well, to start, we have a virtual function. This is a function in the base class that is listed as virtual. Okay? So what's the syntax for that? Well, let's give some syntax. So if I say class, class A doesn't have to be super complicated at all, and I could say maybe public void foo. If I want it to be virtual, I'm going to say that's a virtual void foo. All right, so that's a virtual function right there. That's a virtual function. Now, here's a key. Virtual functions will be overridden. We know this term. It will be overridden in base classes. All right? Virtual functions will be overridden in base classes. Or, derived classes. Sorry, guys. Virtual functions will be overridden in derived classes. All right? So maybe I'll call this base instead. Now, here's another note that we should make. The overridden function in the derived class does not have to be virtual. Meaning that the polymorphism will stop at some point. So before I continue with my notes, let me just kind of put some code in front of your face. And maybe we'll go back to our favorite shape classes. All right, you remember the shapes? Oh, I'm sure you love shapes. So let's go ahead and do that. Where am I? Here's our shape class. I'm going to file save this so I can make changes to it. Hello. Save as. Please take me to my virtuals. Thanks. Thanks. All right. All right, so if you remember, roughly, we're going to kind of speed run this a little bit. We had a base class shape, right? And so it had a few member functions. It had maybe a number of sides, and it had a name. And then we talked about using a constructor. We talked about maybe using this constructor. We talked about using a destructor. And then we have these functions here, print shape and get name. And then we had the square class. And notice that this is the overridden function here, all right? This is the overridden function. It looks like I never got to it. So let me go ahead and define that function for you guys real quick. I'm just going to make a pretty little square. So what does it do? Well, it will print maybe this. And maybe in here it prints that. This is going to be a very lame square. Maybe we can make it a little better. How do you guys like my square? All right. All right, so recall that this is the overridden function. It does belong to the square class. And so, of course, down here, if I define a shape to be S, and I say exactly these two things, I'm going to say, hey, let's get the name of this shape, and let's print that shape. And then we're going to do the exact same thing for a square, SQ. And let's just make sure that we're up to code. We're up to understanding how our code works. Please tell me if you're lost at all. Like I said, we kind of already went over this code a little bit. This is pretty much scratch code though, right? It's only a few lines in there. You guys should be able to understand what a shape is, what a square is, and kind of what things it has. So this is called basic. And if I run the code, notice here that the default shape, this is the default shape, right? And so if we try to print its name, it has no shape. And if I try to print the shape, it says, what do you want me to do? I don't know what to print. But then I create a square, right? Notice that we called the shape constructor, and then we called the square constructor. I then printed the square's name, and I printed the square. All right. So now we're going to introduce the use of virtuals into this. We're going to introduce the work of virtuals. So what is the overridden function here? It happens to be the print shape, all right? So if that is the virtual, I'm going to put virtual here. Now I'm going to show you how this works. So now we have virtual here. Let's kind of review a little bit about what I said with the notes. The first thing I said was, we always have a class plus inheritance, right? So we've got our shape and we've got our square. But there's also dynamic memory involved, in which there's always a pointer to a base class. So this is how this works, all right? This is how this code works. So I said, for one, there is always a pointer to a base class. So what does that look like? Well, we've got a shape pointer. All right, and let's maybe initialize it to be null pointer because I don't want any garbage address in there. All right. So now, do you recall from that gamer code, right? Depending on which function I call, which function I'm going to call. Did you understand what I just said? So let's take a guess, all right? Let's just make sure that we're on the same page here. This one hopefully should be pretty easy. So if I say sPointer dot print shape, am I going to call the print shape from the shape class or the square class? Can anyone tell me? On this line of code, do I call the print shape from the shape class or the square class? At this moment, we're going to understand exactly how virtual functions work. So please, If you haven't been paying attention today, pay attention right now. This is the single most important part of this entire class. So Cherry says shape. Synchro says shape. Coda says square. And Coda, I'm sorry, that's not correct. I was trying to fool you. But notice that this is a shape pointer, and we allocated a shape into it. All right? It's a shape pointer, and we allocated a shape into it. So I'm just going to prevent my memory leak there real quick. And hopefully I don't get fooled. We should see this message, right? This is a default shape. What do you want me to do? And look, it's exactly what we saw. All right, so Synchro and Cherry, you're completely correct. We printed the shape one. But now, let's say I do this. Which print shape do we see? And Coda, if you want to take another guess, I would love for you to do it. Now I'm allocating a square into here, right? Squares are shapes. Squares are shapes. Which print shape do we see? Now we'll see the square. Exactly. I know. This is basic. It's kind of goofy question. But this is the single most important thing for you to understand what the virtual does. Okay? So now watch. I'm going to see if you guys are paying attention. Let's say I come up here and I take out the virtual. I say goodbye, virtual. So now that I've removed the virtual from this overridden function, and I run this exact same code, what class does the print shape come from? Now that I've removed the virtual from the base class, where will the print shape come from? Cherry says shape. I think so. I think so. So now I ask the question, do you understand what the virtual specification does? Do you understand exactly what the virtual thing does? Seeker asks, do we still have two functions in both? Yes, we do. Here's the square. Here's the shape. So kind of in plain English, if the function is specified to be virtual, the program will follow the inheritance chain down to the bottom to determine what type the object actually is. So we're going to play more examples of this. Kind of in plain English, though, it says, if the function is specified to be virtual, the program will follow the inheritance chain down to the bottom, and it will figure out, maybe not to the bottom, but to the type that's stored in the pointer. Let's change that. How's this? No, how's this, Synchro? Is this better? If the function is specified to be virtual, the program will follow the inheritance chain down to the type that's stored within the pointer. So if this is virtual, let me bring it back. If this is virtual, now whatever I store in here, that's where it will go to. So if I make it a shape, it will go down to whatever type is stored within the pointer. What type is stored in there? It's a shape. If I make it a square, at the moment I call this virtual function, it's going to follow the inheritance chain until it finds square. Once it finds square, it's going to print that shape. So let's do another example here. Let me make a second square class for fun. And let's see how far the virtual will take us. Let's see how far the virtual will take us. We're going to make square 2 here. And you know what? I want the square 2 to inherit from the square. So let me ask you this. Is the square 2 a shape? What do you think? Notice that square 2 is inheriting from square, not from shape. So is square 2 a shape? Let me know what you think. Yes. Yeah, it's pretty easy, right? A square 2 is a square, and a square is a shape. It's a chain, right? It's an inheritance chain. It's an inheritance chain. So let's pretend that this square is even bigger. This is going to be the mega square. All right, we've got an even bigger square now. So let's see what it does. I am 100% allowed to allocate square 2 into shape. Now notice, this is very important. Notice that this print shape is virtual. Notice that this one is not. This one is not virtual. Let's see what it does. Let's see what happens. First off, I have to fix my syntax errors. Sorry, everybody. I think that should fix it. I did a whole copy-paste there, and I forgot to change all my names. What is that? What is that coming from? Is that the big square? Is that the small square? It's the big square. It's the big square. So, once again, applause. Thank you, thank you. I'll do a bow for you. It follows the chain all the way down. Now let's try this. I want to see what you guys think. What if I did this? What do you guys think? What do you guys think? So notice now this is no longer a shape. This is a square. And notice in the square class, the print shape function is not virtual. Are we going to see the small square or the big square? What do you guys think? Notice we're not storing the base class in there. We are storing a base class in the pointer. mgisto says small. Kodamax says small. Yeah, I kind of like the way you guys think, but let's see what happens. That's disgusting. You guys confused yet? I agreed with you guys. I'm not going to lie. This is how I embarrassed myself last semester. Cherry says big. Maybe she saw it already, but... this is how I embarrassed myself last semester. Now, why is that? Are you confused yet? You should be. Why did we see that? Well, yeah, once again, it's a chain. Someone cue Fleetwood Mac in here. The reason is because of this. So this, notice what I'm highlighting. A square is a shape. All right, we know this. A square is a shape. So every square contains, if I wanted to come down here and I wanted to say this, I 100% could do this. Every square contains a print shape from the very, very base class. From the base class, it contains this function. I can call it. Look, I can call it right here. I can literally call it. And so even though this happens to be a square and not a shape, that virtual function still exists within the class somewhere. And so I hope you can kind of store that in your head. Attacker says the virtual at the top still dictates everything under it. Absolutely. That's exactly what's happening. That's exactly what's happening. All right? So remember, this square, it's got this ghost. There's a ghost virtual hanging out in here. And because that ghost virtual is hanging out, it's going to dictate everything. Now, if I made a new function, right? If I made a new function in here called void, you know, new print or something. This new print does not exist in the base class, so you kind of restart everything over. Meaning that you would start from the square class instead of the shape class. But yeah, so I'm going to leave it at that. All right, so I hope that your gears are turning and you understand roughly what this virtual does, all right? What this virtual says and how it works. And so next class, we're going to finish up the notes. We'll finish up this example for any other. We're going to have to do a few more things in this example. And then we'll fix our gamer code. And then assignment 5 will be coming out. So if you've got any questions, let me know. Synchro says this was one of the better topics for my brain. I think it was for all of us a little bit because we've already talked about inheritance. But who knows? Maybe it is just a better topic in general. I think if anything, the virtuals will help better explain inheritance for those of us who still struggle with that. But it is kind of a cool little thing. So we're going to have some fun with it. For those of you who were here at the beginning of a class listening to my little rant, and then I showed you my little terminal Minecraft code, that's the inheritance assignment. All blocks in Minecraft inherit from a base block. All ores in Minecraft inherit from a base ore. And when you dig them up, they perform differently. Do you think in Minecraft they've got 17 function overloads, or do you think they use virtual functions? They use virtual functions. So, yeah. So I'm off my soapbox now. You guys are free to go. Thank you for coming to class today. You make my day every day that I see you in the chat. Please get started on that string program and tell me which of those functions is the scariest for you so I can help you guys get that assignment going. All right? Let me know. Other than that, I hope you have a great rest of your Tuesday. Don't burn in the inferno as always. And I will see you guys next time. You are welcome. You are welcome. Thank you. You do too. Goodbye, everybody. Stream's going down here. Unless someone stops me. You are welcome.